Okay, so these are notes on momentum. You've already talked about what this is basically, and we read a article on Actively Learn about momentum, and it's really, momentum is talking about how big something is and how fast it is. And really the big part is just its mass, and then how fast is velocity. But also here you see another term that we haven't quite gone over yet, and that's impulse. And impulse really is dealing with a couple things. It's dealing with force in time, and then it's going to be a change in momentum. We'll talk about that in a minute. Okay, so the equation for momentum is P equals m times v. And again, this is the mass, and this is the velocity. And it's just a simple calculation. You just take the mass times the velocity, and that tells you how much momentum it has. And really, the important part to remember is it has to have velocity. So if it's not moving, it has no momentum. Okay. But let's look at an example problem here, and I'm going to move this down. So we see here it says a car with a mass of 1.5 times 10 to the third kilograms has a velocity of 15 meters per second. What is the momentum? So as we said before, P equals m times v. So we take the mass, and we'll just change this into, take the decimal away in the scientific notation. So 10 to the third, we move it 3 spaces, 1, 2, 3. So it's going to be 1500 for the mass. And that's going to be times the velocity of 15. Okay, and then we just use our calculator here. So we'll go 1500 times 15, 2250, 22,500. So then that's our answer. And then the unit is going to be kilograms, which is the mass, times meters per second, which is the velocity. And that's all you're doing. You're taking the mass, kilograms, and you're taking the velocity, meters per second, and you're multiplying them, right? So that's the unit for it. There's no special unit. Sometimes they have, like for power it was watt, or joules it was for work and energy. This one does not have a special one. So it's kilograms times meters per second. Okay, so that's kind of how you do one. And it could give you, different missing factors. It could give you the amount of momentum and its velocity, and you could figure out the mass just by isolating that variable by itself. But you should be able to do any of those. But the next issue or topic to talk about is this idea. If you remember at the beginning, we talked about impulse. And so if we add that here, and this is saying how is force related to momentum, and that's really talking about something called impulse. And if you think about it, if we want to change the momentum of something, so if a car is moving at a certain speed down the road, say it's going this way, and it's going 25 meters per second, and we want to stop it, so we want to end up with, this is our velocity initial, and let's say we actually want to speed it up. So velocity final is going to be 35 meters per second. So what kind of force does that take? So we know that if we want to change the motion of something, forces have to be imbalanced, and so there must be a greater force pushing on it than is opposing it, and friction and such, so it causes it to go faster. So the things we need to consider for this is the force and the time as well. So we applied a force, and how long did we apply a force as well, and that'll tell us this idea of impulse. And really impulse is these two things, force times time. So if it asks you to solve for the impulse, all you have to do is do this delta P, which is the change in momentum, which can be mass, velocity, final, minus mass, velocity, initial. and then calculate these out. And what's really interesting to remember, important to remember, is the mass isn't going to change of the car unless people get out of it or something falls off the car. So we could actually remove this undo the distributive property and just say m times velocity final minus velocity initial. And then we would be able to figure out what is the impulse, the force, and the time. Okay. So let's keep going. So here's an example. What is the impulse needed to stop a 1,500 kilogram car down from a velocity, let's say, to stop, let's change this a little bit here, to stop a 15 kilogram car that is moving, just add this, at a velocity of 35 meters per second. So if you remember the equation, I'm going to change that on your notes. Ft equals delta P, or the change in momentum. Okay, so then we're going to figure this out together. So we're not going to know the force or the time, but we're going to know if we multiply them together, what would they be? And we'll look at how to separate these in a minute. But so we want to know this number, and we know the change in momentum is equal to mass, velocity final, minus velocity initial. Okay, and so the mass is 1,500, and then we have this velocity final is 0 minus 35. Okay, and then we have a negative 35. We're going to multiply that by 1,500. So we do the math. $52,500 is our answer. Put it over here. It's going to be a negative answer. Don't let that worry you, because the negative is just talking about the direction of the force. So the force is acting against the motion of the car that way. If the car is moving this way, it could really mean the other way. It's just saying it's a force that's against the motion of the car, because this includes a force. Now, it could never be a negative time because you can't go back in time, but because the force could be negative, this impulse could be negative. Okay. And really, we could say, instead of using this negative, we could say a direction like east or west or north or south, like that, and it would make more sense. Perhaps. Okay, so then if we continue here, and so how does time get involved and force get involved in this? So if we added another variable to this problem here, okay, so we could say the same thing, but we could say in 3 seconds. Okay. So then once we get a time in there, we now know we're solving for force. And we start off with this equation again. Ft equals the change in momentum. Okay. And then we want to solve, we have the time, so then we can rearrange this equation to equal the force equals the change in momentum divided by the time. Okay, we already calculated the change in momentum, which is 52,500. And then we just need to divide it by 3 seconds. We do our calculator again. So 52,500 divided by 3, 17,500. And then this is a force, so it's going to be newtons. Okay, so that's kind of how you do the force part. Now, if you wanted to just do the time, we would then say, so I'm going to erase this here. Let's go back. So we'll leave that one. So let's say instead of time, we wanted to instead say we had a force of 5,000 newtons. How long would that take to stop it? So if we have this, if we apply a force now of 5,000 newtons to change it from 35 to 0, how long would that take? So instead of moving the time over, we do the force. So this now becomes T equals the change in P over the force. Okay, now we're going to have smaller numbers, but again we ended up with negative 52.5. And again, we don't worry so much about the negative because the force is going to be negative and it would cancel out. But really it's just a direction. Then we would divide by 5,000. And that's going to give us, we use our calculator again. Let's clear this. So it'd be 52,500 divided by 5,000, 10.5 seconds. So if you're moving along in this car with that mass, you apply this force, it'll take you 10.5 seconds to go from this speed to 0. So that's kind of the 3 examples of those. There's one other thing that you need to know, and that's stopping distance. So I'm actually going to erase this, and we'll move down here and we'll be done. So this one says, what is the stopping distance? So how far would it travel if we did all this? Okay, and we just need the change in time, and we'll just say it's the 5,000 newtons, and so that's going to give us 10.5. We'll just plug in. So change of x, we don't know. Okay, and that's going to be 1/2. And then the velocity final is 0, so plus the velocity initial is 35, so it's going to end up being 35. Okay, and then change in time is going to be 10.5. And we just do the math then. So let's do this, and then we'll know how far is it going to travel. So we do 35 times 10.5. We divide by 2. It'd be 183 meters. Or about 184 meters. So in this car, if you apply that force and you go from 35 to 0, in that time, it's going to take 184 meters to do it. That's kind of the 3 examples. Let me know if you have any questions, and you can go ahead and do practice A and B if you want.